Have you ever wondered what the most expensive photograph ever taken looks like? Well, we're about to dive into it. Because that one picture, taken by the James Webb Space Telescope, didn't just show us something new, it showed us something that, according to everything we thought we knew, shouldn't even exist. It's a discovery so big, it's forcing us to literally rewrite the first chapter of the universe.
So, let's get into it. The story really starts with an absolutely mind-boggling price tag. Because, to understand the discovery, you first have to appreciate the incredible machine that made it all possible.
That's right, $10 billion. That was the cost of the James Webb Space Telescope. It's the most powerful, most complex, most expensive eye on the universe humanity has ever dreamed of building. And all of that money, all that effort, was basically an investment in answering one single epic question.
That one question? Where did all this come from? The whole point of the telescope was to be a time machine. Its mission was to look back, way back, over 13 billion years, and capture the faintest, most ancient light from the very first stars and galaxies as they were just blinking into existence. But here's where it gets wild. When that first real data came back, scientists were just floored. And to really get why this was so shocking, we need to take a step back and look at the cosmic story that, until now, we were all pretty sure we had figured out.
See, for decades, we've had this really well-established timeline for the universe. It's a sequence of events that has been taught in textbooks, and honestly, it made perfect sense. It was our cosmic creation story.
And that story went something like this. First, the Big Bang. Then, for hundreds of millions of years, pretty much darkness. Then finally, the very first stars start to ignite. And only after that, slowly, gradually, do these first little clumpy infant galaxies start to form. The key word here is slow. The whole story was about a gradual evolution, where complexity takes billions and billions of years to build up.
Now, this whole timeline is a core part of what scientists call the standard model of cosmology. The easiest way to think of it is as the official rulebook for how the universe works. It's a theory that's been tested and confirmed over and over for decades, well, until now.
So you have to ask, how in the world did this one telescope get a view so powerful it could challenge a model that's been the bedrock of cosmology for so long? Well, the answer is all in its absolutely groundbreaking technology.
You see, Webb isn't just a bigger version of the Hubble telescope we all know and love. It's a completely different kind of beast. While Hubble mostly sees visible light, the same stuff our eyes see, Webb is a specialized time machine. It sees the universe in infrared light. That lets it do two amazing things: peer through thick clouds of cosmic dust, and, crucially, pick up the faint, stretched-out heat signature from the most distant things in the universe. When you combine all its superpowers, that huge golden mirror that acts like a giant light bucket, its infrared vision, and the fact that it's parked a million miles away from Earth to stay incredibly cold, you get an instrument that can see the cosmic dawn. It can see the very first glimmers of structure in the entire universe.
And what Webb saw in that cosmic dawn, well, it was the scientific equivalent of finding a fully built skyscraper in an ancient archaeological dig. It just made no sense. It completely broke the timeline.
According to the rulebook, the standard model, the first galaxies should have been messy little toddlers. Small, clumpy collections of stars that were just starting to get their act together. Instead, Webb found cosmic adults. We're talking massive, well-structured galaxies that looked shockingly mature, almost like our own Milky Way. But here's the kicker. They were existing just 500 to 700 million years after the Big Bang. The problem, the really crucial point, is that our models say there simply wasn't enough time for these giants to form. It's supposed to take billions of years for gravity to pull that much stuff together and organize it into a big, beautiful, mature galaxy. Seeing them this early isn't just surprising, it's a flat-out contradiction of the rules.
So this isn't about making a small adjustment to the timeline. No, this means that the rulebook we've been using, the standard model, is missing a huge, very, very important chapter about how the universe got started.
So what happens now? How does this one finding force us to redraw our entire map of the cosmos? Because this isn't just about how galaxies form. It could get into the fundamental physics that governs everything. The ripple effects from this are just enormous. For one, the whole timeline for galaxy formation has to be squeezed down a lot. The early universe must have been way more chaotic and way more efficient at building big things than we ever gave it credit for. And here's the most exciting part. It hints that there might be some kind of new physics out there, forces or processes we don't even know about, that were supercharging this growth at the dawn of time. It's honestly a humbling and kind of thrilling reminder that the universe is still packed with incredible surprises. It turns out for every question we answer, we find a dozen new ones we never even imagined asking. That $10 billion price tag, it wasn't just for a picture. It was for a brand new perspective on where we all came from. And that really is the question Webb leaves us with, isn't it? It's still out there, a million miles away, just staring into that beautiful, unknown darkness. What other impossible things is it about to find? What other rules is it about to break? All we can do is wait and wonder.